Hey everyone, welcome to Unit 4, Topic 2. Today we are going to be looking at some big picture stuff for the topic, which is exponential functions. So through this video, should be kind of short and sweet. By the end, our goal is to determine which function grows faster, linear functions or exponential functions. So let's get going here and try and do some exploration to see which one grows faster. So if we look at this first table, we can see that my change going from 8 to 18 is I'm adding 10 here. 18 to 28, I'm adding 10 here. Adding 10 and adding 10 each time. So that change of plus 10 makes us go up relatively quickly. But what I want you to see in the other table is that even though I'm starting with the same thing, I get even bigger. I get bigger even quicker. So how am I getting there even with the same four parts of my table? Well, what change am I looking in here? I'm going from 8 to 16. And so maybe your first thought is to add 8. But then if you check your next change, am I adding 8 again? I'm not. So what pattern do you see going from 8 to 16? Well, that's also multiplying by 2. And 16 to 32, I'm taking 16 times 2 to get 32. Same thing to go from 32 to 64 and 64 to 128. So what's happening here is that my multiplication, that when the change is a multiply, even though I'm multiplying by a number that's smaller, I am getting much larger than if I was just adding. Multiplying grows your numbers much faster than adding your numbers. And the same thing goes with dividing and subtracting. Dividing as your change will have a much greater difference in your table than subtracting does. So let's make some more connections with that. If you remember back to Unit 2, linear functions are ones that add or subtract. But we are going to be introducing and talking through in this unit exponential functions. And through the last example, maybe you can guess, exponential functions, the change is going to be multiplying or dividing. And that's going to make a much bigger difference in a smaller amount of time versus adding or subtracting. So here's a reminder of what the equation looked like in a linear function. We learned that this little triangle guy, this delta is what we call it, represents my change. And again, in a linear function, that's going to be adding or subtracting. And the f of 0 is going to be our starting value. In other words, the y-intercept. Okay, we learned that in Unit 2, and so as we're going to apply that knowledge to what we know, or what we're going to go forward with exponential, we are doing the exact same symbols here. Okay, the equation part is just going to be in a little bit of a different order. So this f of 0 is still going to represent that starting value when x is 0. So that's going to stand for our y-intercept. And the delta is still going to stand for our change. In this particular case, though, with exponentials, we have a special name for that change, and we call it the common ratio. So we're using the same symbols, and that's great, but some of these symbols are really kind of confusing. So we're actually going to simplify it a little bit, just like we have used for a linear equation. We've used kind of an alternative to this kind of gross looking formula. We've used something that we've called y-intercept form, which is y equals mx plus b. It's saying the same thing. My m is talking about my change, or my rate of change in this case, or slope. And the b stands for my y-intercept, but this is just a little bit easier to look at. Same thing is going to be true in this exponential function. I'm going to have an easier on the eyes equation that we're going to use. And that one is this one right here. y equals a times b to the x. Now make sure that we understand that there's a multiply between the a and the b, and that the only thing being taken to the exponent is the b. Okay? Again, how we're connecting these two, the f of 0 is our y-intercept, and our y-intercept, instead of being that f parentheses 0 parentheses, is going to be the a, and the change, or the common ratio, is going to be our b. So those equations are great and all, and those are going to be very useful and helpful for us, but I also want to give us a big picture of what our graphs are going to look like. So if I'm looking at the coordinate plane, a linear equation makes a line, so either that line is going to go up or it's going to go down, again depending on if you're adding or if you're subtracting. In an exponential function, as we saw though, I am getting bigger at a faster rate, and so every time there's going to be a different number that I'm adding or subtracting, and so I'm not just going to go up in a straight line. I'm going to get bigger faster. So if I'm getting bigger, if I'm multiplying, it's going to look like this, or if I'm getting smaller, it's going to look like this. So notice that it's not a straight line. You are not changing in the exact same way like you are in a linear equation, but you're going up faster or you're going down faster. So for just 3 really quick practice problems, just understanding this exponential function equation, I'm just going to ask in each one of these, what is the y-intercept and what is the common ratio? So we're just going to match it up based on what the equation that we see. So right here I see a 2, and that matches up with the y-intercept. So the y-intercept for this equation is 2, and the number 5 matches up with the common ratio here. So the common ratio is 5. Same idea for the next one. What number matches up with the y-intercept? Well, that's going to be a 4, so the y-intercept is 4. And the common ratio is matching up right here. Well, whoa, that number's a fraction. Is that okay? Definitely. The common ratio is just 1 over 3, or 1/3. The third example, though, the third equation here, I feel like a number is missing. Okay, so what number is going to go out in front of the 8? So I see that the 8 is to the x power, so what number, or what does the 8 represent? Well, it's the base of my exponent of x, so I know that that's going to represent my common ratio. So my common ratio is 8. But what about my y-intercept? Okay, if I don't see a number out in front, and I know that I'm multiplying, what number can I multiply by 8 to the x and have it stay 8 to the x? Well, the only number with that property is a 1. So in this particular situation, my y-intercept is a 1. Now just do a couple quick practice problems on your own, and we will be done for today. Good job. Good first day.